Okay, so this lesson is going to be on writing word problems for systems of equations, which we've looked at a little bit. You all really know all the skills to do this. We just haven't looked at any of these specific problems, so we're going to do that together during this lesson. So the first thing I want you to do is pause the video and read through. You can do one word problem at a time or all of them. Underline anything that you realize are key words. Okay, so in this first question, I noticed that it tells me that jeans cost $40 each. That's a key word. T-shirts cost $20 each. I know that there's a total of $160 being spent, and there are 5 total items. Now, this is a question of systems, which means I'm going to end up needing probably 2 equations and 2 variables. And I know when I read the last problem, they are actually asking me for 2 different things. They're asking me how many pairs of jeans and how many t-shirts. So those are going to be my 2 different variables that I'm solving for. So we've talked about this before. If you see 2 rate words, then that means we're going to, within the same context, that means we're going to end up writing something in standard form. So if I go ahead and write standard form for this, that's going to be 40x plus 20y equals 160. And I think you all are all probably pretty good with that. We did say that we needed to define what our 2 variables were, so we probably want to make an additional statement that says x stands for, let's see, that was for jeans, and that y then is going to stand for t-shirts. Now, the part that I think most people are going to get stuck on is this part that says there's 5 items, because we haven't used that before. But think about what X stands for again. All right, X stands for the number of jeans. So if we're buying 5 items total, that means I'm buying some amount of jeans that I don't know. That's X. And I'm also buying an unknown amount of t-shirts. That's Y. And when I leave the store, or when Joe leaves the store, he's going to have 5 things total in his bag. So the first equation, if you want to take an extra note for yourself, this first equation, notice, is all talking about money. $40, $20, $160. The second equation is only talking about actual physical items. It has nothing to do with money. It's just saying the physical number of jeans plus the physical number of t-shirts equals 5. And then this is a question that we already know how to solve. Based on how we wrote this system, this question is best going to be solved using elimination, because both of them are in standard form. And I'm going to need to multiply one of these to be able to solve that. So this is going to be an elimination problem. And then what I would like for you to do after you've taken all these notes is go back and try to solve each of these, and we'll check those tomorrow just to make sure you know how to solve these problems. Okay, so here's our second example, and if you haven't done so already, I want for you to pause the video, underline what you think is important, and if you can go ahead and set this problem up, that'll give us a place to start. All right, so I see we've got $10 for a membership, $100 for each movie. There's a rate word. And then a different service, Blitz Video, is going to give me $15 for a membership and 50 cents per movie. So that gives me another rate word. They're asking me how many movies would I need to download for the services to have identical costs. That means for them to be the same or equal, which means I'm trying to actually set up the atomic stream equal to Blitz Video. So if I do that, I think most of you probably would have written an equation that looks something like 10 plus 1x equals 15 plus 0.50x. All right, and then you should have gone ahead and defined that x equals the number of movies. Most of you are not going to think this problem is any different than what we've done before. So if you got that, pause the video real quick and go ahead and work that out. All right, I'm going to subtract 50 cents from each side, or 50x rather, so that's going to be 10 plus 0.50x equals 15, minus 10 from both sides, 0.50x equals 5, and then divide by 0.50 on both sides, which is going to give me x is 10. So to answer the first part of the question, how many movies would you need to download? The answer then I would say is 10 movies. And then this actually asks a follow-up question. It says, what is the cost? Because I want to know, when is the cost the same? And that's if you download 10. But what is that cost? Well, again, I think most of you probably understand that to do that, we need to plug that back in. And we should be able to plug that back into either side, because no matter where we plug it in, we want the cost to be the same. So either place, if I plug that in, you should be getting that the cost, so if I do 10 plus 1 times 10, no matter where you do this, you should be getting that the cost is going to be $20. So I think that most of you are able to do that without a system. Now, what I want to show you is what this looks like if they give you a multiple choice answer for a system, so that you can see how this matches. So let me go ahead and give you what the answer would be if it was on how to write this as a system if it was multiple choice. All right, so this is the same problem set up, instead of as an equation, set up as a system. So I want you to just kind of take a second to compare and see how they're setting this up. So pause the video if you need to. So notice that the x is still defined the same way. Both of these x's are defined as the number of movies. And all they've done is taken these two parts that we know are going to be equal and split them into two separate equations. One of the equations for atomic stream, the other one for blitz video. And then the last thing they did is, because we want these to be equal, we know that the amount that we want to be equal is the cost, so they defined y to be the cost. So what we're going to work on tomorrow, I know you all can solve these, and we are going to work on solving those just to make sure you feel good, but we're also going to talk about what's the equivalent system set up, so that if you have to write it as a system, or if you have to choose for multiple choice for a system, you know what is equivalent there. All right, so let's look at our last example, and this really is a review of last week. We're kind of tying some two things together there. So as I've said before, pause the video if you need to. Go ahead and underline and identify your important information. All right, so I see 60 cents per foot. Rope B costs 90 cents. Didn't do that right, 90 cents per foot. John needs to buy at least 15 feet of rope. And then he wants to spend no more than $18. So a few different things here. One, I see that there are two rates. And if I look at all of the, thinking back to example 1, if I look at all of these pieces, they all have money in them, which to me tells me that they're all going to go together in the same equation. And also, I notice, I'm even going to correct myself, I notice words like no more than and at least, which means I'm actually going to end up writing inequalities. So if I write this first inequality to do with money, I'm going to say I've got 0.60 x plus 0.90 y is no more than, that means less than or equal to, 18. And you all already know this. X stands for rope A, how much rope A, and Y is going to stand for rope B. Like I said, I think you all are pretty good on that part. So now think back to the last one, to question 1. So we've already used these other 3 numbers, so I'm not going to use them again. I've already used them. The only number I have left to use is the fact that he needs to buy at least 15 feet of rope. So now we're just talking about quantity, not a money amount. So if I talk just about quantity, at least 15 feet of rope is some unknown amount of rope A, that's X, plus some other unknown amount of rope B, that's Y, needs to be at least, that's greater than or equal to, 15. All right, so make sure you understand how I'm setting that up. And then notice that they give us a graph, because there is no way to solve inequality systems without a graph. And last week we talked about how we just need to set this up because it's in standard form with word problems, set up your 2 equations and figure out where your intercepts need to be. So I'm actually going to give you a minute to pause the video and see if you can graph this first problem and shade and do solid and dashed correctly. Okay, so for my 2 intercepts, I ended up getting 10.2 for the X and 20 for the Y. This is a solid line, and the first one is going to be shaded below, so I'm going to kind of shade below here as best I can. All right, and then if I solve this second one, and when I split that up, I'm going to have an x-intercept at 15 and a y-intercept at 15. So 15 and 15. Again, that's going to end up being a solid line. And this one says greater than or equal to, so we're going to shade above. So I'm going to go ahead and do that, shade above, which is really going to get me like this whole section out here. And what I'm looking for are possible solutions. So remember, we're looking for the overlap. So this solution area is going to be this skinny little area right here. And I just want to name really one. What's one solution that I know is in there that's going to meet the criteria? And the one that I notice the best with my lines is this 214 right here. So one possible solution is 2 feet of rope A, and let's see, that's 14 feet of rope B. All right, so hopefully after watching this video, you feel a little bit better about some of these word problems. Some of you probably feel a lot better because you were already feeling pretty good to begin with, so this just confirmed that you know what you're doing. We're going to work on these together tomorrow, so make sure you have notes taken.